Okay, hi guys, so we'll be continuing on seeing more on Schrodinger wave equation. So just to tell a note before starting that when we tell phi, so phi doesn't have any physical significance until we write something like phi square. So phi, sorry, psi, not phi. So this does not have any direct significance. Okay, psi square is actually referred to as probability density. Okay, and we already know that r square r, as we saw the graphs of r square r in our previous lectures, or if not, so we'll be seeing the graph of the same in the coming lecture. Okay, so I think till now we haven't seen it, but okay, so we'll be seeing them in the next coming lectures. Okay, no worries there. So r square r is nothing but the radial probability density. So this is radial probability density. Okay, then, and actually psi square is a measure of finding probability at a certain point in space. So better align that measure of finding probability at a certain point in space. At a certain point in space. Okay, so then let's see the rules before that. So more is the value of psi square, more is the probability of finding an electron at a given point. Okay, so we will always talk in terms of probability, not the exact position of electron in any of the orbits or orbitals or subshells uh, or anything. So now, as we discussed the functions or radial part of wave functions in the previous lecture, so let's actually look at some of the rules that govern the formation of a particular equation or formation of a particular radial part function. Okay, so rules for seeing radial part function. So r would be something like c times f of sigma to the power radial node, or nodes rather. So this is the maximum radial nodes we are referring to here. Then sigma to the power l. L is nothing but azimuthal quantum number. Then we have e to the power minus sigma by 2. Okay, so l is nothing but azimuthal quantum number. Then we have radial nodes, which is um, directly implicit here. So example of function could be, we actually saw this function in the case of 6s orbital. So 6 minus sigma square. Okay, then let us see so now let us see some of the graphs of the radial wave function or radial part of wave function. So some of the graphs, so we have, let's say, a graph of 1s orbital. So it would be starting from a non-zero value rather, and this is the graph between rr and r. This would be something like this positive sign here. Then let's see the graph of 2s. So for 2s our graph would be something like this positive, rather not, there will only be a one radial node. This will be positive, this will be negative. Now let's this first graphs we are looking for s orbital, which always start from non-zero values. Next let us look at 3s orbital. So for 3s, this is r of r versus r. So for 3s we would having something like this as the function. Okay, positive, negative and positive here. Okay, so here we had one radial node, and for 3s we would be having 2 radial nodes. Okay, so now let's see for 4s. For 4s we'll be having something like or rather 3 radial nodes, positive, negative, and negative. So we have 3 radial nodes here in the graph of 4s. Okay, so let me write some of the nodes on the same, that all RR graphs for s orbital start from non-zero value. RR versus R graphs for s orbital starts from non-zero value. Okay, then for PDF orbitals all RR graphs starts from 0. For PDF orbitals all RR graphs start from non-zero value. Okay, so let's see the graph of r square r, as I was talking in the starting of the video. So r square r graph would be just a superimposition of the negative values, or rather not a superimposition, just a mirror image of the negative value on the graph towards the positive side of the x-axis. Okay, so for 2s the graph would look something like this. Okay, so the graph for RR versus R for 2s was something like this, but for r square r it would be the positive value, so both would be positive. In case of RR versus R, this value was negative. Okay, but that is not the case here, so I'm just erasing it. And for 3s again we would be having something like this as our r square r versus r graph. Again starting from the non-zero value, 2 radial nodes here. By the way, there was 1 radial node here, positive, positive, and positive. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more graphs on 2p, 3p, and then d, f, and g orbitals, and then we'll be seeing important formulas on the same. So till then, good luck and goodbye.